Hello everyone, I'm Cameron, welcome to my second video. Today we're going to be covering asymmetric RSA cryptography, the most widely used method of encryption today. It does exist on the opposite end of the mathematical spectrum from frequency analysis, my last video, in that method can be done by anybody with no mathematical background and the patience to do it, whereas this method involves a lot of heavy calculations and mathematical ideas that might seem complex if someone doesn't have the background knowledge. I'll try and summarise it in as simple language as I can for you, but if you don't understand it fully, I would urge you to look online for resources that can help you get a broader understanding, as it is a very interesting topic. We'll start with some history again. RSA cryptography was developed in 1977 in the USA by these three men, Ronald Rivest, Adolf Shamir and Leonard Edelman. That's where it gets its name, RSA. However, it was actually developed previously by a group of mathematicians led by this man, Clifford Cox. They were working at GCHQ in the UK, and they actually had developed the entire same system, but by 1975. And this was not public knowledge whatsoever until 1997, when Clifford Cox revealed it at a conference that they had actually been doing this for years. So asymmetric RSA is called public key cryptography in that the key used to encrypt the message is widely available to everybody. Everybody knows it. And I'll show you this diagram, shows you well how the system works. So the sender will take his plain text, encrypt it using the public key, and then that will give the ciphertext, but then the recipient can use their private key to decrypt it, meaning that only they can decrypt it and no one else. This is also good as it's called asymmetric, since the encryption and decryption are done using different keys. The whole core behind RCA is based around modular arithmetic. Now this can be quite complicated, but I'll try and explain it in the simplest way as I can. A nice easy way of describing it would be to say that if you have a number x and you divide it by n, if you get left with a remainder y, taking you back to primary school, we would then say that x is congruent to y mod n. And so for example you could say that 3 is congruent to 5 mod 2. You could also say that it is congruent to 31 mod 2 or 1 mod 2. In standard practice we use the smallest remainder possible, so in that case it would be 3 is congruent to 1 mod 2 would be the standard way you write that. Now RSA cryptography works by incorporating powers of these modulo n, so you'll be raising them to powers that are huge prime numbers, hundreds of digits long. And this is called a one-way function, as it's more or less impossible for a human to factor this massive number back into its two starting blocks, whereas it's very easy for anyone to multiply them to get the key. Butchered that a little bit, but I hope that made some sense. To give an anecdote to sort of show exactly how difficult it can be to decrypt this, in 1977, shortly after RSA was published, there was a challenge issued in a scientific magazine that said if you can decrypt this passage of text, I'll give you $100. He gave them the key, which as you can see there is n, it's 129 digits long. It took 17 years before anyone managed to decrypt this. It took a group of 600 volunteers multiple days to eventually come out with the two prime numbers that made up the factors, which are p and q here. They are 64 and 65 digits long. And to apply that to today's practices, usually RSA cryptography is done with numbers hundreds, thousands, even millions of digits long. So as you can see, very difficult to break down. This is the formula for RSA cryptography here on the board for encrypting and decrypting. And it involves taking your text, manipulating it with the congruences to mod n, raising them to powers that are dependent on the public key to get your encryption, and then the recipient would take that encrypted text, put it back into the formula, do some more manipulation of powers with the congruences to get back the plain text at the end. Now, that's a very simple way of summarising how it works. I hope you enjoyed. If you found any of my two videos interesting, please look up further on the topic. It's a very interesting, fascinating area of mathematics. I highly recommend reading as much literature as you can on it. As you can see, based on the complexity of the system, unless there's a new method discovered for factoring massive numbers easily, then for the next few years at least, this was going to be the most widespread system, as today it is essentially unbreakable. Thanks for watching. Let us know any other topics you want us to cover in future videos. Yeah, see you next time.